Right. So last time we discussed about two methods of sending data from one place to another in a network. So when you want to send data from one point to another point, uh, the first technique we call packet switching, where when you want to send some message, it will break into small pieces, and these are sent from through various ways, right? For example, in the figure shows you that. So the message is broken into pieces and they may take different parts. And at the end, right, it'll again combine together to form the message, right? In circuit switching, this is the traditional way, like early days when we want to have voice conversation, especially with the fixed phones or telephones. So this is how we will create. So basically, you are creating a physical link between two parties. Physical in the sense like it's wired, but in the middle we have what we call switches, and switches will connect to each other to form the path. So that will create a fixed path between the uh, two telephones. Right. Now let's look at or compare the two. So when we talk about you know two connections, we can compare packet switching and circuit switching. So let's start with that. Right. So let's compare packet switching. We have already know now what happens here. And then let's compare this with the circuit switching. So let's compare packet switching versus circuit switching. Right. Now, few things that we have already discussed. Right. First of all, if you look at the link between the two, packet switching, there's no physical link. There's no fixed path, right? And circuit switching, there's a physical link, the fixed path between the two parties. That is the first one. Right. So the first one, let's take down. So in packet switching, we can say the first point. So in this case, we have no physical link path between the two parties, right? And in circuit switching, we can say there's a physical link path between two parties. So that is the first thing we can talk about when it comes to packet switching and circuit switching. So we can say that message is broken into pieces, we can say packets, which takes different parts. Isn't it? We talk about this, and messages is broken into, and they'll take different parts. So the second one, we can say it will take the same path. Takes same So as a third point, we can say in packet switching, it can use a lot of resources because it can go through many nodes. As you can see, they are taken different paths. So we can say efficient use of network resources. So that means it will use most of the network resources available. But here it physically establishes a connection, right? So we can say it's a limited use of network resources. Okay, so that is one thing we can talk about. Examples. So packet switching is used in different protocols like internet protocol, or IP, or Ethernet. So that these are the techniques, and we already discussed that in previously its use of examples, traditional telephone network or lease lines. Right. So the question that we are going to discuss from this point is, what is the role of transport control protocol, right? There are many protocols we are going to use. Protocol means how two computers communicate to each other, right? So the first one is, there's a question that we are using IP addresses. I hope you remember we discussed any computer in a network, we can uniquely identify using this IP address, which is a unique number, four numbers separated by dots, which computers use to communicate to each other. The first question is, this is not sufficient. When you want to deliver a message from one computer to another computer, we can say one host to another host. Because when you take a computer, it can run many applications, right? So in a computer, there could be many applications. So the issue is, how do you make sure that when you want to send data from one place to another place, it is not just two computers. There are many applications which sends the messages. So we want to identify how or which applications send data from one place to another place. So to distinguish this, we are using something called port numbers. Now, for example, if you want to send emails, so we are using an email application between two computers. So we have to use a protocol for that, right? So port number we can use together with IP address to uniquely identify these different processes, right? So different applications uses different protocols. If you want to send emails, we are using a protocol called SMTP. If you want to send web pages, we are using HTTP. If you want to send the web pages securely, we are using HTTPS. Similarly, if you transfer files, we are using file transfer protocol. Okay, I think now we should, take down these things. So let's write down, right? Okay. So the question is, we'll put up as the first question, right? We can ask why the IP address is not sufficient, right? So when we ask IP address, that we could ask like why this is not sufficient, right? To deliver a message from one place to another place. Right. Okay. So as I told you earlier, we can say the first point is we can have multiple applications. So when you say a computer, it can run multiple network applications. That is the very first thing that we need to discuss. So we have multiple network applications. So when you have multiple network application, we want to sure this will deliver the message into correct application. So for this, right, we have to communicate these application through different port numbers. So we are using different port numbers to communicate to each number. So simply we can say we can use both port number as well as IP address when you want to talk about different processes. So now let's look at some examples, right? So when you talk about examples, we are going to talk about so let me take some examples. So let's write down some port numbers. The First one, I'm going to use port protocol, right? So simply what this protocol is, and then we use what network layers. Network layers we will discuss later on, and I explained there why this, and then port number details, right? Okay, so when you are going to talk about different protocols, we want to know what a protocol is, and then port number, and then, right? Um, right, the first one is, we can talk about SMTP. So SMTP is used, SMTP stand for simple, we call simple mail transfer protocol, and which is used in a transport layer. So we say TCP, and then the port number is number 25, right? Port number is 25. So this is how we will use it. So the network layer is TCP, and the port number is 25. Right. That is simple main transfer protocol, or SMTP. Then we have hypertext transfer protocol, which is HTTP. Hypertext transfer protocol equal hypertext transfer protocol, especially when you work with the web pages. This is what we are going to use. The protocol again comes under transport layer, transport control protocol. It's a transport layer, and then the port number is number 80. So traditionally, number 80 is used. Similarly, we can have HTTPS. I told you like HTTPS means hypertext, same thing. Hypertext transfer protocol, we call secure. And then port number is 443. we can have file transfer protocol, FTP. Again comes under transport protocol. The port number is could be 20 or could be 21. So there could be many others, right? We can talk about under this. So now we discuss that IP address is not sufficient, and then different processors wants to communicate to each other. For that, we have to use port numbers, right? The next one is we need to discuss the idea of multiplexing in networking, and the idea is we could use multiple applications, right? And multiple endpoints we same, and we can use port and port numbers, right? So that's the idea of multiplexing, right? So let's write down these multiple endpoints. So we discussed this idea earlier, but we but the idea of multiplexing we want to discuss. So let's write down this. So the idea of multiplexing, right? So the idea of multiplexing is right. So the multiplexing idea is right. Now we were discussing about the idea of multiplexing. Multiplexing is it's a technique we use to combine multiple data in single medium, single physical medium, right? So we can say the idea of multiplexing is right. So the multiplexing is the idea of a technique. It's used in network when you want to transfer multiple data over one physical medium, right? And when you want to do that, we are using a device called multiplexer. So a multiplexer which combines inputs, multiple inputs to a single output, right? And it takes multiple data and then into a single data stream. So that is the first step. So the device is called multiplexer. So it's the one actually combines everything into one. So we can say multiplexer or a mux is what we need to use, right? Now, one end, we combine everything together so that we can send it to one link. But the other end, we need to, separate this data, because I told you in the earlier that this data is sent into different applications. So the computer needs to identify which application uses which data. So for that, we won't use demultiplexer. So demultiplexer is used to separate, right? So the next one is we want to talk about is demultiplexer, because at the receiving end, demultiplexer should take this, right? It's called demarks. So we can say a demultiplexer or demarks is used to separate the combined data in individual data streams. So this is used in various places: telephone networks, satellite communication, and also in computer networks, right? Which efficiently uses this. So what you need to remember is we need you need to know that multiple data items are combined, and this process is known as multiplexing. So when you are sending, we put multiple data into one, and then you send. Receiver in ending, you separate it. The device we use is called multiplexer in the sending. In the receiving end, the single data separate from multiple devices, we call demultiplexer. So the next section, we are going to talk about two main protocols. That is user datagram protocol. In short, we say UDP. It's a communication protocol. And then the other one is called TCP, right? So we are going to discuss their properties and also some applications and the difference between these, two protocols. So let's start with the UDP first, right? So the first protocol that we are going to talk about in detail is called user datagram protocol. User datagram protocol, right? In short, we say UDP. So one of the extensively used protocol, right? It's called user datagram protocol. So later on, we are going to discuss protocol suite we call TCP/IP. Under that, we are going to talk about this. I will discuss this later on. Now, what will happen in UDP is it's called connectionless protocol. Connectionless in the meaning that it is not verified. So simply when you're sending the data, receiver will not acknowledge. It doesn't tell whether the receiver sends the data or not, because that it's faster. Now, when you take different applications, right? Like when you want to streaming videos like YouTube, right? Audio, Sometimes data might be lost, but there's no harm. Similarly, in gaming also, like especially online gaming, the UDP is used. Okay, loss is not a problem at all, right? And DNS, remember domain name system we discussed. Whenever you have a URL, and if you want to find out the IP address, we are going to use DNS. Again, comes under UDP. And voice over IP, which is when you want to transmit voice data in an IP network, we are using VoIP. That is also acceptable. So this is what we call user datagram protocol. Right. So let's write down. So we can say the protocol, this one is a part of TCP and IP, which we are going to discuss. Actually, that is another lesson where we discuss what protocols are, but UDP is a part of TCP and IP protocols. And the main idea is when you're sending, you are not getting any acknowledgement. That means whether the sender is received the data or not. So it's simply sender and receiver, then keep on, request and response without any confirmation, right? So the problem with this is there could be data loss and it will not retransmit. So sometimes data might be lost. So that is one of the issues, right? Data might be lost in between, and then there's no resend. So when you want to have a reliable connection, this is not acceptable. We say unreliable, right? So when you look at different applications, I told you like sending voice over internet protocol, we call VoIP, voice over IP, DNS, and also like online gaming and music streaming. So these are some, example applications, right? So these are some example applications. So since the UDP is not reliable, which means no acknowledgement from the recipient side. So when you need a reliable communication, we have to use a different protocol. So this part we are going to talk about what we call transmission control protocol, which is considered as a reliable protocol. So let's start looking at transmission control protocol. Right. Now, in transmission control protocol, the idea is you have to have a reliable connection. So it establishes a connection between sender and receiver, and this is normally called handshake, right? You first make the connection between the two parties. Once you have this connection, then sender can start sending the data. And once the data is sent, right? And then receiver should confirm. So the point is, let's say the send is sending, the receiving ends, if you are not receiving the data for some time period, it is considered as a data lost. And then it will again ask to reset. Right. So we can say that in transmission control protocol, or in TCP, the first thing is it establishes a connection between these two. And then the other point is how do you establish the connection, which we known as what we call handshake. Once you establish this connection, the sender can send data and then should confirm, right? So what are the applications? So let's write down some example applications. So let's write down some example application, right? So what are the example applications we can have, right? Web browsing, email, file transfer, remote access, meaning like uh, um, you can log into faraway computers, we call remote computers, and also database access. Like the data, it's within database protocols, right? Which use database access. So here are like some applications where we can talk about how TCP use. Right. Now that we have discussed both UDP and TCP, we can have a small graphic which shows you how this happens. Okay, so let's see the difference between the transport control protocol and user datagram protocol in a graphical view. So as I told you earlier, transport control protocol is connection oriented, which actually before sending data is establish a connection, and then once you send, you wait for the acknowledgement. In UDP, user datagram protocol, it's not like that. So there's no connection establishment, it just send and receive data. So in that way, it's very faster. So with this one, we finished the section 6.8, which is about the protocols. And the next one, we are going to look at different applications available on the internet, like how the domain name systems or DNS work, domain names, the hypertext transfer protocol. So these are the main things that we are going to discuss under this part, right? So this is 6.9. So let's start. So section 6.9, basically we are going to explore applications, some applications on the internet, right? Okay. So under this one, we are going to talk about a couple of ideas.